now, I'm going to welcome to the stage my colleague, Dr. Scott Counts, who is going to talk to you about antibody treatments for Alzheimer's disease.
So can I just, like that? Okay, perfect. Hi, everyone. Yasmin and Rebecca and Cassidy, I've been watching students give talks for a really long time now. And and I have to say those were absolutely outstanding. So collective round of applause for our students. I also know how nervous you probably were, so way to fake your way through that as well. You're cool, calm, and collected. So that's the way you want it. So treatments. So like for the last few decades, we've really only had a handful of drugs. You've heard some of these, Exelon and Aricept and Namenda, and these drugs are basically designed just to provide symptomatic relief. And all that really means is that they're not there to slow down the disease. They're not capable of doing that, okay? But what they are capable of doing is just helping you cope with the disease a little bit better, And in some cases, that can maybe keep someone out of a home or assisted living or skilled facility for, a few months, again, which a collective socioeconomic impact is pretty big. But what we really want is a drug that can slow down the disease. And so for the last 20 years or so, one of the major focuses for these, what we would call disease-modifying, disease-slowing drugs, has been targeting the amyloid that builds up in the brain as in the form of plaques. And Yasmin addressed this briefly when she was talking about Alzheimer's disease and the cellular components, okay? And so you probably heard in the press in the last several years about these drugs that are coming through. They're trying to get FDA approval, and will Medicare and Medicaid cover it, and all these different issues. So I just wanted to take us through that real briefly, just to so we can kind of just have an idea where we all are with this. So, well, first of all, these are the little amyloid plaques. This is like a microscopic, through the microscope, using a special stain, and we have these amyloid plaques in our brains, and of course those are abnormal. And again, the theory is that the amyloid that forms these plaques is sort of one of the prime movers of the disease. So if we can get rid of these plaques, then maybe we can improve cognitive function and slow down the disease progression, right? And so the way that we're trying to target these amyloid plaques is through antibody treatments, okay? And so so antibodies are just a part of our natural defense system, right? They recognize, attack, and remove foreign invaders, right? So COVID would be a big one, right, from recent memory. If you got infected with COVID, well, your body would make these antibodies to COVID, and then it would try and fight it off. And well, that means that the next time you would get it, you would come out much better because you'd have these antibodies already there, ready to go attack it and get it out of your body, right? And so what scientists have done is actually leveraged this natural defense system. And so what they're doing is they're making their own antibodies in a test tube, basically, right? So this isn't anything your body's making. It's the scientists making these antibodies, and then they can go in and infuse into your bloodstream. So again, they're done in these infusion clinics, right? And then they can go in and recognize and attack and remove specific targets. And a lot of these antibody therapies are to cancer cells, a lot of them. So you see like Keytruda, for instance, on the commercials. A lot of these attack inflammation cells, so like, Skyrizi and Humira. Of course, if you watch TV for even 2 hours, you'll see all of these different antibody drugs in succession. Try watching Frasier at like 9 o'clock at night, But this new line are these antibodies that attack AD pathology, and specifically the ones we're talking about are the ones that attack this pathology. Okay, and again, like I said, these are the first drugs, FDA-approved drugs, to come into play in a long time. The question is, are they effective enough? Okay, and so you may remember this from a few years back. This was the big breakthrough, this aducanumab, and especially when you're watching TV. Anytime you see this MAB at the end of the drug name, not the trade name, but the drug name, that means that just that AB at the end means antibody. Okay, so you'll see just how many of these drugs are actually antibody drugs. It's pretty amazing. But what this drug did, and what this is showing here on the left, and this is looking at, so kind of like when we were looking at the bright colored spots, the red spots. In this case, these are the amyloid plaques in the brain, okay? And so these are different people that had different doses of this drug, okay? And this is 1 year later. So the person that had the placebo, so just an infusion with no antibody in it, their plaques were still there, but people with these increasing doses of the drug, their plaques were cleared, okay? So they cleared the plaques, so that should slow cognitive decline. Well, it sort of did. So what they did is they had 2 clinical trials that were done the exact same way, but they got 2 different outcomes, okay? One worked a little bit, so we don't have to worry about these scales. This is just how the drug companies show this data, so it's, just so you can see what, we see. And so, this is the drug here. This is the drug here giving us less decline and cognitive decline rather. And this is our placebo. That was about 20%. But in this trial, there was really no difference at all. So what happened? There was a lot of controversy, okay? The other part that was controversial were the side effects. And so what they found with this aducanumab drug were these, so this is a side effect, and I've actually started to see this in the newspapers more and more, so you'll probably start to see this. It's called ARIA, and the scientific meaning for this is what they call it amyloid-related imaging abnormality. Practically what they're talking about are basically brain swelling and brain bleeds, okay? Not good. And so 35% of the patients were showing this brain swelling or brain bleeds, even though the average rate of decline or slowing was only about 20%, and that was only in 1 trial. So the FDA advisory panel had a lot of concerns about this, but there was such an overwhelming unmet need for just some sort of drug to slow things down that the FDA granted it this so-called accelerated approval, and what that meant was that they wanted further trials to look at the safety profile. And in fact, Medicare and Medicaid wouldn't even cover the drug until they got these other trials done, okay? Most of the major, again, it was marketed as Aduhelm, most of the major medical centers, including here in Michigan, decided not to offer the drug. There were warning signs starting to emerge where the drug was in use. Not to go into this too much, but this is actually just showing an artery that's been broken from all the amyloid that's been built up inside of the blood vessel. And again, that's a problem of the drug. It's clearing those plaques out, but then the plaques are getting caught in the vessels. And so that's what's causing the brain bleeds and the swelling and all that. And so it's actually going to be discontinued this fall. So they're just not going to have it on the shelves anymore. But there are some new therapies that are coming along that they're proving more palatable to doctors because the data is a little more convincing. The first of these is called lecanemab, and you're going to start seeing this on TV. Okay, this was actually approved by the FDA, full approval in 2023, just last year. And what they basically showed, this is the drug, and this is the placebo here. And they showed there's actually about close to 30% slowing of cognitive decline over 18 months and fewer side effects. Okay, so if you look down here, there's our aducanumab. Again, the mixed results, and then 35% side effects. Here we're getting a solid 27, 30% slowing, and obviously much less side effects. So that was good. And so again, traditional FDA approval, Medicare and Medicaid is going to cover this. There's still going to be this is twice every 2-week infusion, which again is a lot. And it's still pretty expensive. It's not as expensive as some cancer drugs, for instance. And there is going to be this copay. But start looking for this Leqembi coming to a commercial site near you. The next one up, and this one's actually pending FDA approval, and this is the drug from Lilly. This is donanemab, and so this is in just two different tests where, again, what you see are the drug actually slowing cognitive decline versus the placebo, and this was in 2 different sort of tests that they did to assess the cognitive decline, okay? And so they actually saw 35% slowing of decline, which again is now better than the other drug, right? And what was interesting about this is that 50% of the subjects were actually able to stop taking the drug after a year because all the plaques were gone. Okay, also 50% of the subjects remained stable during the first year. So instead of declining during that first year, they just kind of stayed stable, which is great because most everyone's going to be declining in that year. Okay, but now again we're getting this sort of uptick again in those side effects of the swelling and the brain bleed. So, maybe there's a trade-off. The better, excuse me. The better the clearance, the more gets stuck and then causes these side effect problems. And I think that's actually what the FDA is looking at right now is some of the more of the safety data. But one of the main barriers to therapeutic efficacy is what's called brain penetration, right? And that's because we have this protective barrier, if you will, called the blood-brain barrier, okay? And that limits access to the brain. So when you infuse things into the bloodstream, only so much can get into the brain, okay? And so, first of all, that limits access of the antibody drugs to the brain. So if you're taking an infusion for a cancer drug and it's just going to, an organ out here, then it'll get straight there. That's fine. So that's pretty effective. But trying to get into the brain is much less effective. Okay, and so it requires just lots of infusions, and that becomes expensive, and you have to get to the clinic and all of these other barriers to this. But what it also does is it limits that amyloid clearance out of the brain, and that's what's leading to these side effects. And so now we have these new strategies to try and kind of work around the blood-brain barrier, right, to get things in easier and get things out easier, right? And so there was this clinical trials in Alzheimer's disease, which is a big conference, and this was just last October. And they introduced this new drug called trontinemab. Who comes up with these names? I don't know. But anyway, it's an amyloid antibody, but it's combined with another custom antibody that can attach to the blood-brain barrier and then kind of get everything in. So it's almost like a Trojan horse, just sort of tricking its way into the brain, right? And so the other interesting thing about this drug is that you only need it once per month instead of once every 2 weeks. And so even at once a month, it's clearing all those plaques out in like 6 months and producing very little of those side effects. So that could be a new strategy to help us improve how these drugs are delivered. And then we could start seeing improvements in cognitive slowing of past like 30% or so, right? And so we can really start to see a difference in how these drugs are working. There are a lot of other drugs in the pipeline. Next time I'm here, I'll tell you all about them. But that's where we are for now. But leading into Graham's talk, I just wanted to mention that there's another innovative strategy to try and trick the brain into taking these drugs in, and that's using ultrasound. And so Graham's going to tell us about that. Oh.